Welcome, my dear students, and I am Ravi Shankar. See, we are studying about the atomic physics as well as the nuclear physics. In the last video, we have studied about the production of cathode rays or the discovery of electrons by J.J. Thomson. So we have proved that the beam of electrons is nothing but the cathode rays, or cathode rays is nothing but the beam of electrons. That is, inside the discharge tube, when the pressure of the gas is in the order of 0.01 millimeter of mercury, some of the invisible rays emanating from the surface of the cathode, which produces the fluorescence on the walls of the discharge tube, called to be cathode rays, which are later on found that they are nothing but electrons. For that electrons, we are going to determine the specific charge. What do you mean by this specific charge of an electron? See, when you are considering the specific charge of an electron, it is otherwise called to be charge to mass ratio. So charge of the electron divided by the mass of the electron, otherwise it is called to be specific charge or normalized charge, which is the charge of the electron is given to be E, and the mass of the electron is considered to be m, and the specific charge of the electron is found to be a constant, which is 1.7592 into 10 to the power of 11 coulomb per kilogram. See, this specific charge of the electron was found by or determined by J.J. Thomson. So this determination of specific charge of the electron can be performed or can be done with the help of J.J. Thomson experiment. So we are going to study about this J.J. Thomson's experiment, with the help of which this E by m, specific charge of an electron or charge per mass ratio, is going to get calculated. See, when you are considering the specific charge of this electron, what is the principle that was being used to determine this specific charge? The beam of electrons or the cathode rays is affected both by electric and magnetic fields. By applying a suitable electrical field or by applying a suitable magnetic field, the cathode rays or the beam of electrons gets deflected from its original path. That concept is taken to be the principle for determining the specific charge. So the principle is, we can say, one of the property that the cathode rays gets deflected or the cathode rays get deflected both by electric and magnetic fields. Electric and magnetic fields. This concept of deflection produced by electric and magnetic fields on the cathode rays is taken as the principle behind the determination of the specific charge or E by m. So let us consider about the construction of the apparatus. See, when you are considering the construction of this apparatus, let us take the apparatus consists of a discharge tube. So if it is a discharge tube, you will be having a long glass tube or a quartz tube. And the other end of this glass tube or quartz tube is in the form of a funnel, a broad end. And this broad end, bell-shaped or a funnel-shaped, and this broad end is closed with an fluorescent screen. So this end, it is having a screen called to be fluorescent screen, usually on ordinary screen coated with fluorescent materials like zinc, barium platinocyanide, or zinc sulfide. Over that screen, when cathode rays are made to fall on it, you can able to see bright spots or scintillations called to be fluorescent spots. Then inside this, some gas is being enclosed and the discharge tube is evacuated to a low pressure in the order of 0.01 millimeter of mercury. At one end, you will be having an filament, and by supplying the current through the filament gets heated. Because of that filament, the cathode that is placed in front of the filament gets heated up. So this we are calling it out as the cathode C. And this coil of wire, let us consider it as F. And using a low tension battery, through that filament, we can supply the electrical current so that the filament gets heated. Indirectly, the material called to be the metal plate cathode is getting heated up. Beyond this cathode, you will be having a circular disc which is acting as an anode. So you'll be having two parallel circular discs which are acting like what? Which are acting like the anodes A1 and A2. Or in some cases, there will be only one anode. And at the center of the anode, you will be having a small hole so that the electron beam that is coming out of the cathode, after passing through these anode holes, they will be rendered as an fine beam and traveling in a straight line, striking an bright spot or producing a bright spot by striking the fluorescent screen at one particular point, and let us take that point as O. See, when the electron beam is passing through this discharge tube, there are two plates which are kept parallel to each other, and the two plates are represented as A and B, and that the two plates are generally called to be deflecting plates, because in between the two plates a large potential is being developed so that an electrical field is developed between the two plates which can able to deflect the beam of electrons or the cathode rays passing in between. Then in perpendicular to the applied electrical field, using a pair of coils or using a large electromagnet, we have to supply what? We have to supply a uniform magnetic field perpendicular to that of the electrical field applied with the help of the pole pieces of the magnet called to be the North Pole and the South Pole. In between the cathode and the anode, a very large potential in the order of about 50 kilovolt is applied in order to make the electron beam to get accelerated. The electron beam which is coming out of the cathode is attracted towards the anode so that the electron beam is said to get accelerated. That electron beam is accelerated by applying a large potential difference in between the cathode and the anode in the order of 50 kilovolts. So the electron beam which is coming out with a greater velocity after passing through the anode is allowed to pass through two parallel metal plates called to be deflecting plates or deflector plates. See, by passing it through the deflector plates, by applying a suitable electrical field or by applying a suitable magnetic field, we can make the beam of electron to get deflected either to a point P, or we can make it to get deflected to another point called to be P dash. Whether it is deflecting towards P or to P dash depends on the applied electrical field or magnetic field. So this we are calling it out as the construction or the description of the apparatus. See what I have told now. I will write it out in terms of theory. You just follow me, and if you are taking notes, you just take it out. See what are the descriptions that I have to write regarding this discharge tube. See, first of all, a highly evacuated discharge tube is taken. So the first point, a highly evacuated, okay, a highly evacuated discharge tube is considered, or a discharge tube is taken. Okay. Number two, see, when a highly evacuated discharge tube is taken, then the cathode rays are produced inside the discharge tube. So the cathode rays produced inside the discharge tube, the cathode rays which are produced inside the discharge tube, inside the discharge tube is accelerated, okay, is accelerated towards the anode, towards the anode by applying, by applying a large potential difference in the order of, large potential difference in the order of 50 kilovolt. This is point number 2. What is point number 3? See, the accelerated cathode rays, when passed through the small hole in the anode, then they are converted into a narrow beam or a fine beam of cathode rays. See, in the anode discs, we can say in the anode discs, there is a pinhole. There is a pinhole at its center, at its center. Then we can consider the fourth point, when the accelerated cathode ray, when the accelerated cathode ray passes through the anode, passes through the anodes, they are rendered as, they are rendered as a fine or a narrow beam of cathode rays. So a narrow or a fine beam of cathode rays is produced by passing that cathode rays through the small hole or the narrow hole or the pinhole in the anode discs. Then point number 5, that cathode rays, the cathode, that cathode rays coming out of the anode. So we are writing like this, that cathode rays are allowed to pass through, are allowed to pass through, allowed to pass through two parallel plates, two parallel plates which are called as deflector plates, which are called as deflector plates. So the beam of electrons or the cathode rays that is coming out of the anode discs is allowed to pass through what? Is allowed to pass through two plates, which we are calling it out as what? Which we are calling it out as the, what we are taking, we are calling it out as the two parallel plates known as the deflector plates. How should be the deflector plates? Let us consider point number 6. How should be the deflector plates? The deflector plates, okay, that deflector plates should be maintained at, should be maintained at a high potential difference, maintained at a high potential difference, so that so that an electrical field is available in between the two plates, because electrical field A is equal to V by D, potential difference divided by distance. The two plates are separated by a small distance. When you are applying a large potential difference, then in between the two plates a large electrical field will be developed. So the deflector plate should be maintained at high potential difference so that an electrical field E is maintained, or an electrical field E is acting in between the two plates, is acting in between the two plates. Okay, in between the two plates. Then what we have to do? See, perpendicular to that of the applied electrical field, we have to supply a magnetic field in such a way that, or with the help of the permanent pole pieces of a permanent magnet, or with the help of the two coils of wire which can act as electromagnet. So we are saying perpendicular to the applied electrical field, perpendicular to the applied electrical field, we have to apply the magnetic field is applied, or magnetic field is produced. Magnetic field is produced either with the help of, either with the help of pole pieces of permanent magnet, pole pieces of a magnet, or or with the help of an electromagnet, or with electromagnet. So by supplying the electrical current to the coils of wire, that electromagnet can act as it can able to produce magnetic field, and the produced magnetic field is perpendicular to that of what? Perpendicular to that of applied electrical field. That means the applied electrical field and magnetic fields are acting on the beam of electrons perpendicular to each other. Then point 8. What is that point 8? When no fields are acting, when no fields are acting, what will happen? That is, when no fields are acting means when there is no electrical field or when there is no magnetic field. The cathode ray or the electron beam. Okay, let us consider the cathode ray. The cathode ray travel in a straight line, or travels in a straight line, and strikes the fluorescent screen, strikes the screen coated with, that is fluorescent screen, screen coated with zinc sulfide or barium platinocyanide, or barium platinocyanide, which acts as fluorescent screen, which acts as a fluorescent screen. So when no field is acting, the cathode ray travel in a straight line, strikes the fluorescent screen. So strikes, let us put a comma here. So let us put a comma here. So strikes a fluorescent screen to produce a bright spot, to produce a fluorescent spot, or we can say to produce a bright spot at what? At the point O. So let us consider this as the description. Hope you should have understood what I have written here. Since the second volume book is not being supplied to you, I have taken, or I have given the notes. Try to copy it out, or try to download it, or try to take a screenshot, whatever may be. By some means, you to study this so that you can able to get it easily. Okay. So the description, I have given it out as 8 points. What I have told, I have written it here. Now, I have to determine E by M. First of all, in order to determine the E by M, the velocity of the cathode rays should be determined first. So first of all, I am going to determine what? I am going to determine the velocity of what? Velocity of the cathode ray. So determination, let us write like this: determination of the velocity V, velocity V of what? Velocity V of cathode rays. Okay, how you can able to get determination of? the velocity of V of the cathode rays. Let us calculate. See, let us consider how to calculate the velocity of the electron. Now, we have to apply an electrical field in between the two plates. So when I am, see, you are having like this, isn't it? You are having two plates like this. By applying unsuitable electrical field, one is positive and another one is negative. By applying unsuitable electrical field, the electron beam which is going in a straight line will get deflected towards the positive terminal because because we can say the electron is negatively charged. When no electrical field is applied, the electron will be going in a straight line to reach the point O. But when I am applying a potential difference so that in between the two plates, if an electrical field E is applied, then because of this electrical field, the electron beam will be deflected towards one end or positive end. Now, for this applied or a fixed electrical field, you apply a magnetic field B. When this fixed electrical field is there, you apply a magnetic field B perpendicular to the electrical field E. What will happen? Because of this magnetic field, a force will be developed on the electron, which will try to bring the deflected electron to its original position. So you have to apply an suitable magnetic field for the fixed electrical field in such a way that the deflected beam of electron or the cathode ray should again come to its original position. Are you able to understand? See, first of all, I am writing. What I am writing? First, initially, an electrical field is applied. Initially, an electrical field E is applied. When you are applying this electrical field, then the beam, the cathode ray or the electron beam gets deflected. The cathode ray gets deflected from its original position. Now, for that fixed electrical field, perpendicular to it, apply an magnetic field, in such a way that the deflected beam of electron or the deflected cathode ray should come to its original position. Should come to O, to its original position O. Why it happens? Because when you are applying an electrical field on that charged particle, because a cathode ray is a charged particle having a charge minus E. Because of the applied electrical field on that charged particle, a force will be developed. That force makes the beam of electrons to get deflect from its original path towards the positive terminal. Now, when you are applying magnetic field, you might have studied in the third lesson, magnetic Lorentz force. Force acting on a moving charged particle inside the magnetic field, given by the formula BQV sin theta. Here, the applied magnetic field is perpendicular. So the force due to magnetic field is B into E into V. That force brings that deflected beam of electron to its original path. When the force produced by the electrical field and the force produced by the magnetic field balances each other, then the deflected beam will come to its original position. So that is with the help of that concept alone, we are going to determine the velocity of the cathode rays. That is what I have written here. Hope you should have understood. You see, initially in between the two plates, you apply the electrical field. When you are applying the electrical field, then the force developed on that charged particle due to the electrical field produces a deflection. Now, perpendicular to the applied electrical field, you apply a magnetic field. That magnetic field now produces another force on that charged particle, which brings that deflected beam of electron to its original path. This will happen only when the force produced for deflection by the electrical field is equal to the force produced by magnetic field to restore. So let us calculate the velocity using this concept. What I have to calculate now? First of all, I have to calculate then what is the force on the electron beam or the charged particle due to electrical field. So I am writing force on the cathode ray, force on the cathode ray due to electric field is equal to, let us consider it as F, which is equal to E into Q. Instead of Q, we are having the charge of the electron as E. Similarly, when you are applying the magnetic field, a force will be developed on the charged particle due to the magnetic field. So I am writing force on the cathode ray particle, force on the cathode ray particle due to magnetic field, due to magnetic field. Again, that value is F. What is the value? The equation is B into E into V into sine theta. Since magnetic field B is perpendicular to the direction of the cathode ray, theta equal to 90. So sine 90 becomes 1. Therefore, the force F is equal to B into E into V. Now we can say when there is no deflection in the cathode ray, when there is no deflection in the cathode ray or in the electron beam, when there is no deflection in the cathode ray, then we can say E into E is equal to B into E into V. That is, the force developed on the charged particle by the electrical field is equal to force developed on the cathode ray particle by the magnetic field. So in this case, we can say this charge E and E will get cancelled. Therefore, what is the value of the velocity? Velocity V is equal to E divided by B. So we have calculated the velocity of the cathode ray particle, or the velocity of the electron is given to be V, which is equal to E by B. So we have calculated what? We have calculated the velocity of the beam of cathode ray or the electron traveling from cathode to the fluorescent screen. Now we are going to determine E by M. The value of E by M can be determined in 3 steps or in 3 ways. So this is common for all. Let us go for the first method, by which the determination of specific charge can be done. So we are going to determine first method. Let us consider this as the first method. Up to this, common for all. Now, first method, we are going to determine. So determination of E by M. So how we are going to determine the value of E by M? Let us consider. See, the cathode rays, from where it had started and accelerated, means the cathode rays are coming out of cathode and they are accelerated from the cathode to anode. So the electron beam is having the potential energy at the cathode, which is converted into kinetic energy when it reaches the anode. Isn't it? The electron beam is, or the electron is coming out of the cathode. So it is the cathode ray. It is having large amount of energy initially. It is at rest, potential energy. When it is attracted towards the anode, it starts to move. So the kinetic energy converted into potential energy while it reaches the anode. This is the first point. So we have to calculate what is the, according to the law of conservation of energy, we can say the potential energy available is equal to the kinetic energy that was being developed. By equating these two, we can able to determine the E by M, a basic method. Let us consider. See, let us write. since the cathode rays, since the cathode rays are accelerated, since the cathode rays are accelerated from where? From the cathode, from the cathode, from the cathode to where? To anode. Okay, let us consider like this. From the cathode to anode, we can say the potential energy of the electron is converted into is converted into kinetic energy of the electron beam, of the electron beam where? At anode, at anode. So at cathode it is having potential energy, while it is accelerated towards the anode, it is moving with the velocity v, which is given here. So it is converted, potential energy converted into electrical energy. Let us write like this. Let capital V be the potential difference between cathode and anode, cathode and anode. When you are having a potential difference capital V between cathode and anode, I can calculate the potential energy acquired by the cathode ray, potential energy acquired by the cathode ray. We might have studied about the potential energy of a charged particle in lesson number 1, moving a charge from infinity to a point against the electrical force. So we can say potential energy acquired by the cathode ray is equal to, let us consider it as the charge of the electron E multiplied with the potential V gives you the potential energy. What is the kinetic energy? Then the kinetic energy acquired is given by the general formula, which is equal to half into m into v square. We know according to law of conservation of energy. So we can say according to law of conservation of energy, according to law of conservation of energy, we can say the potential energy available at the cathode is converted into kinetic energy when the cathode ray particle or cathode ray beam travels from cathode to anode. So according to law of conservation of energy, we can say the potential energy is equal to kinetic energy. So E into V is equal to half into m into v square. From this, take this m to the other side. You can write E divided by m equal to half into, we know the velocity v square divided by the potential difference v. But we have calculated the velocity v is equal to E divided by b. Take this and substituting in the above equation the value of the specific charge of the electron, or E by m, is equal to, see, we can write 1 divided by 2 into capital V multiplied with b square, that is capital E square divided by b square. So by knowing the values of the potential difference V, the electrical field E, and the magnetic field B, the value of E by m can be calculated. So I can write by knowing the values of, potential difference capital V between cathode and anode, the applied electrical field E, and the applied magnetic field B between the two plates, the value of E by m can be calculated or can be determined. And it was found out that, and it was found out as 1.7592 into 10 power 11 coulomb per kilogram. This is one of the methods by which you can able to calculate the value of E by m. Let us move on to the second method, by which we can able to determine the E by M. So second method in determination of in determination of E by M. How you can able to determine the value of E by M? By some other method. So let us here consider it as the method 2. Here what we are going to do or how you are going to calculate means we are going to apply the electrical field alone in between the two plates and making the electron beam to get deflected from their original path. We are going to determine what? We are going to determine the value of E by M. Let us consider this as the screen. XY is the screen. These two are the deflector plates A and B. Let us consider the length of the deflector plates as L. The electron beam that is entering with the velocity V. The electrical field E alone is acting in between the two plates between the length of L. So when the electrical field alone is applied due to the force E into E into capital E into small e, the force due to electrical field, the electron beam is getting deflected from the point O to the point P. So what is the amount of displacement produced on the screen? Let us consider it as Y. But the electrical field gets over at this end. So at this end, the amount of deflection produced is taken to be Y dash. See, beyond this Y dash, by inertia or inertial motion, the body is going along or the electron beam is going along this direction and striking the point P. Here there is no deflection. The deflection is taking place inside the electrical field alone. So using this concept also, we can calculate the value of E by M. Let us see how. Here we are going to switch off the magnetic field in between the two plates or which is acting perpendicular to that of the electrical field, and we are going to apply only the electrical field. So in order to determine E by M, the first point is you switch off. Okay, you switch off the magnetic field. Switch off the magnetic field. Now we can say the cathode ray or the beam of electron. Now the cathode ray or the beam of electron is subjected only to the electrical field, is subjected only to the electric field. See, when it is subjected only to the electrical field, what happens? The cathode rays are deflected. So the cathode rays are deflected in vertical direction, in vertical upward direction or in vertical direction, producing a displacement of, vertical displacement of how much? Y in the screen. Y in the screen. Why this happens? This vertical displacement is due to the electrical force developed on the electron. This displacement is due to, okay, this displacement is due to what? This displacement is due to the electric force by electric field on the cathode ray. So what is the electrical force? So I can say force due to electric field. What is that force due to electrical field? I can write F is equal to capital F, capital E into small e. Capital E is the applied electrical field. We have to write Q. Instead of Q, the charge of the electron is E. But in mechanics, we have studied that force F is equal to mass into acceleration. So mass into acceleration is equal to E into E. From that, the acceleration produced on the electron can be calculated as E into E divided by M. So the acceleration velocity already we have calculated. Now we have calculated the acceleration that was being developed. Now we have seen on the screen The vertical displacement produced this y. We have to calculate that value of y. How to calculate? See, let y be the vertical displacement. Let y be the vertical displacement produced on the screen. Produced on what? Produced on the screen. See, but what we have to calculate is, first of all, we have to calculate y dash and then we will relate y. So I am writing, let y dash be the deflection, or y dash be the vertical deflection produced. Y dash be the vertical deflection produced, at the end of the electrical field. At the end of what? At the end of the electrical field. So at the end of the electrical field, the vertical displacement produced this y. I have to calculate that y. How to calculate that y? We know the equations of motion. We know that S is equal to ut plus of at square. Use this formula to calculate what? To calculate the vertical displacement at the end of the electrical field. So S is considered to be y dash. Initial vertical velocity is 0. It is going in the horizontal direction. So this term will become 0. Half into, what is acceleration? In the previous line we have calculated E into E divided by M into T. It is T square. What is T? T is time taken, okay, time taken for the cathode ray, to cross the electrical field, See, we know that the cathode ray is traveling with the velocity v. How much distance in that electrical field it is traveling? The distance traveling is equal to the length of the plate. The length of the plate is L. That is the distance traveled by the electron beam inside the electrical field divided by T. Therefore, the time taken by the electron beam to cross the electrical field is L divided by V. Take this and substitute in the above equation. Therefore, what about y dash? Y dash is equal to half into E into E divided by M into, what is T square? T square is L square divided by V square. Let us take this as equation number 1, or let us take this as, already we have taken the velocity as 1. So let us consider this as equation number 2. You see, what is y dash? The amount of deflection that was being produced at the end of the electrical field. That end of the electrical field is available inside the discharge tube. We can't go and we can't measure the value of y dash inside the discharge tube. So we have to relate the vertical displacement produced on the screen, the fluorescent screen, and the vertical displacement produced at the end of the electrical field. It was found out that the deflection produced on the screen, the deflection produced on the screen, what is the deflection produced on the screen? It is y. Is found to be proportional to the deflection produced inside the discharge tube at the end of the electrical field, that is y dash. So when we are removing that proportionality, we have to introduce a constant. So I am writing y is equal to, in your book it was being given that the constant is c into y dash, where c is a constant, and that constant depends on the geometry of the discharge tube. See, what is the length of the discharge tube? What is the breadth of the discharge tube? What is the length of the plates inside the discharge tube? What is the distance between the two plates in the discharge tube? Like that. The value of this C is determined by the geometry of the discharge tube, which will be provided to us by the manufacturer of the discharge tube. So, but this Y can be measured on the fluorescent screen. What is the initial position? What is the final position? By knowing that, we can able to know the value of Y. So substitute for Y dash. Therefore, we can write Y is equal to C into, what is the value? C into Y dash. What is Y dash? Half into capital E into E divided by M into L square divided by V square. Now what I can do? Now I can substitute for the velocity. But we know that velocity V is equal to E divided by B. Take this and substitute in this equation. You can get Y is equal to C into 1 by 2 into E divided by M into capital E, isn't it? Capital E. What L square is? L square divided by, what is V square? It is E square by B square. So B square can be taken to the numerator. Now you can cancel one of the E. So what is the value of Y now? The value of Y is equal to C into 1 by 2 into E divided by M into L square B square divided by E. Now what we have to calculate? We have to calculate the value of E by M. So take this E by M alone. So I am writing E by M equal to, make a cross multiplication, 2, then Y, here E divided by C L square B square. So by knowing the value of the amount of deflection produced on the screen Y, the applied electrical field E, the constant C, the length of the deflector plate L, and the applied magnetic field B, we can calculate what? We can calculate the value of E by M. Any difficulty? So we can conclude. How we can conclude? See, by knowing. So we can write by knowing the amount of displacement produced on the screen Y, the applied electrical field E, the applied magnetic field B, the constant C, the length of the plate L. By knowing all these, see, we can write like this: C and L, the value of, okay, the value of E by M can be determined, and it was found as E by M equal to 1.7592 into 10 to the power of 11 coulomb per kilogram. So this is the second method by which we can able to determine the value of what? Value of E by M. Similarly, there is one more method. So the third method of determining or determination of the value E by M. See, in this case, what you are going to do? Here also, in between the two plates, that is A and B, when there is no electrical field or magnetic field is applied, the cathode rays are traveling in a straight line and striking the fluorescent screen at the point O. Now, the electrical field is switched off and the magnetic field alone is made to act. When the magnetic field alone is made to act, it is getting deflected in the downward direction, or we can say it is getting deflected in the downward direction so that it can move in a circular path. It can move in a circular path of radius R. Why? Again, in the third lesson you have studied, when a moving charged particle is subjected to a perpendicular magnetic field, the force experienced on that charged particle makes that charged particle to move in a circular path. There you might have calculated the time period and frequency in the third lesson under the topic motion of the charged particle inside a uniform magnetic field. The same concept can be applied here. So here what we are going to do, here we are going to switch on the electrical field, switch off the electrical field, and the magnetic field alone is subjected to act on the cathode ray beam, so that the force experienced on that cathode ray beam by the magnetic field makes it to move in a circular path of radius r. Using that, we can calculate the value of E by M. So what is the concept now in this third method? Now electrical field is switched off. Okay, now the electrical field is switched off. When you are switching off the electrical field, what will happen? The cathode ray beam, okay, the cathode ray is subjected only to magnetic field. When the cathode ray is subjected only to the magnetic field B, what will happen? A force will be developed on the cathode ray by the magnetic field. So force developed on the cathode ray particle, on the cathode ray particle by the magnetic field is equal to, let us write it out as F. General formula B into E into V into sin theta. V is the velocity. See, B into E into V into sin theta, magnetic field is acting perpendicular to that of the plane, perpendicular to that of the cathode ray. So theta becomes 90, sin 90 becomes 1. What will happen? This magnetic force makes the cathode ray to go in a circular path of radius r. So this magnetic force makes the cathode ray to move in a circular path, providing necessary centripetal force. Because if the body is going in a circular path, it experiences centripetal force. That centripetal force is provided by the magnetic force developed on the cathode ray particle by the field. So providing necessary centripetal force. So to move in a circular path, providing necessary centripetal path. Which one? The magnetic force that is developed. What is the magnetic force? Magnetic force is B into E into V. This provides what? This provides centripetal force. What is centripetal force? Centripetal force is given by the formula mv square divided by r, where r is the radius of the circular path. Where r is the radius of what? Radius of the circular path. Any difficulty? So we can say B into E into V is equal to mv square by r. Here you see the velocity V and one of the velocity V will get cancelled. Now I can calculate the value of E by M. Taking M to the other side, I can write E divided by M equal to V divided by B into R. What is V? But we know that the velocity V is equal to E divided by B. So E divided by M is equal to capital E divided by B square into what? B square into R. So using this formula, by knowing the applied electrical field, isn't it? By knowing the applied electrical field, magnetic field, and radius of the circular path, E by M can be calculated. So I can write the conclusion. So I can write by knowing the values of electrical field, magnetic field, and radius, E by M can be determined. And found as, and it was found as how much? E by M equal to 1.7592 into 10 to the power of 11 coulomb per kilogram. So by three methods we have calculated the value of E by M. And in all the three methods, the value of E by M is considered to have the same value. So what are the conclusions that were being arrived from this experiment? See, two conclusions are being arrived. One is the value of E by M. The value of E by M is a constant. The value of E by M is a constant. Number two, the value of E by M is independent of the nature of the gas enclosed, nature of gas enclosed inside the discharge tube, and the nature of electrodes used. Nature of electrodes used as cathode and anode. Cathode and anode. So this is what we are calling it out as the conclusion, because the experiment was being repeated with the different gases enclosed inside the discharge tube using different materials as cathodes and anodes. In all cases, it was found out that, and in all methods, it was found out that the value of E by M is a constant. The value of E by M is found to be 1.7592 into 10 to the power of 11 coulomb per kilogram, and no change was found. So it was concluded that the value of E by M is independent of the nature of the gas enclosed and the nature of the electrodes used as anode and cathode. Hope you should have understood this question, an important question which may be asked for an 5 mark. But all the three methods won't be asked in a single question. Any one of the method will be asked to determine the value of E by M. See, if any one of the method is asked, whatever may be, up to the end of the determination of V is you have to write, isn't it? First of all, before starting to write the methods, either method 1 or method 2 or method 3, you have to write up to what? You have to write up to the determination of velocity. It is a common for all. First of all, we have written, isn't it? See, first of all, we have drawn a diagram. See, the diagram may be somewhat different from that of your book. For easier understanding, I have drawn the diagram like this. In your book, there will be a bulge at the center. Here you may have able to have a bulb-like structure will be alone given. All the other things are being same. So for easy understanding and easy to write the description, I have taken the diagram like this. By understanding the diagram, you can write the description by yourself. After writing the description, you determine the velocity of what? Velocity of the cathode rays. So determine the velocity of the cathode rays as V is equal to E by B. After determining the velocity, you choose any one of the method what it is asked. You write any one of the method to determine E by M. But up to the calculation of E by B, V is equal to E by B. It is common for all methods. Hope you should have understood this concept, I think so. See, patiently go through this again and again and try to write along with me in your notebook, since you are not having your second volume book now. So you write it out and study it out. It will be easier for you to understand and also to have in mind. So it can be easily reproduced. Any one of the method can be easily reproduced. Hope you should have understood. Thank you. Let us see in the next video. Till then, goodbye and thank you from Ravi Shankar. Thank you.